Hello and welcome to my channel. Although by now I have over 100 videos, still only two of them are in English, and those two are the flex power supplies from Tony, and people who watch them repeatedly asked me to do more English videos, so I have decided that I will do one or two videos in English each month, maybe more, we will see. So today on the bench I have several battery packs and chargers from Parkside power tools. I'm not sure how familiar you guys are with Parkside power tools, but here in Romania, they are very popular because they are cheap. Someone asked me to take a look at them. They do not seem to work. The battery seems dead. The chargers don't charge. We will see. Let's start with the bigger one, shall we? Do I have any voltage on it? 12 volts. 12.3. And this should be a 20 volts battery. Here in Romania, Lidl sells Parkside power tools, and we even have a commercial with Arnold Schwarzenegger promoting Parkside power tools. Granted, they are not as reliable as the big brands, but they are way cheaper. We ignore the fact that all of them are very dirty. So, any welding problems? I did had some battery packs with detached welding points. Not on this side. No, they don't seem to be. These two seems to be the ends of the battery packs. 12 volts. There are 5 series and 2 parallel cells, meaning we should have 20 volts, but we don't. Let's measure each cell's voltage. 3.2, 3.13, not very well balanced. 3.2, what do you mean nothing? How could there be nothing? There are 2 parallel cells. One of them could be dead, but both? And the last 2.8. How on earth could 2 cells completely die? These two Don't seem to have any voltage on them. Look, nothing. But why? Is there a short on this side of the BMS? Seems to be, but I'm not sure if that's the battery resistance or indeed the BMS is dead. I think I will desolder the BMS and then redo the measurements. And the board is finally out. It was a bit of a struggle, but it's out. Lots of lead-free solder, big tracks. So let's redo the measurements. This is the minus side. So, not on the resistance. There we go. 2.8. So this is the dead. These are the dead cells. Yes. 3.2. 3.1. 3.2. So these two seem to be dead. They were connected between here and here. So is there a short? Doesn't seem to be. Then what? Why would they die? Why would they be completely dead? No, no shorts. Do they take any current? I have my programmable power supply set to 4.2 volts. And limited to 2 amps. And I have my DC clamp meter here to see if they take any current. Yes, they do. And indeed they are very discharged. Look. I do not have any new cells to replace them, so I want to at least try to revive them if it is possible. Something is definitely wrong. The voltage does not increase at all. It should have jumped to over 2 volts. Look, the other ones do charge up. See? The voltage does rise up, but not on these two. I thought I would check for shorted MOSFETs on the BMS, but there aren't any. Look, this is the minus side of the battery pack, and this is the minus side of the output. They are connected straight together with this shunt, and the plus also. What is the point of having a BMS if I don't have a MOSFET to cut out the output when the cells are to discharge? There seems to be an IC here, maybe some microcontroller or ASIC, but I don't see the point of a BMS without any MOSFETs. When the cell voltage drops below, I don't know what, 2.9, 2.8 volts, the BMS should cut out the output to protect them. This is another battery, a smaller one, smaller in capacity, but the voltage should be the same, 20 volts. So let's see. Do I have any Of course not on resistance. Do I have my 20 volts here? No, of course not. How on earth do you design a BMS without any MOSFETs? This one has a diode blown up. Why would that diode blow up? I am not sure. But let's see the voltage on each individual cell. So this is the minus side. Dead. 2.98. 3.1. 2.9. So another battery pack with a dead cell. And this is the top of the diode's case, right? The other half anyway. Do I have all the batteries dead in this fashion? I'm not even gonna bother taking out the board, at least not yet. I have two more of the same battery, so let's check them. Of course not. Of course not. All of them are dead. And this is a Torx screw. This is an Allen key. First cell 3.6. Second cell 3.6. Third cell 3.6. Fourth cell. What do you mean 12 volts? And the last one, 3.7. How on earth could I have this voltage here? Same stuff. Seems to be the same BMS as the bigger battery. Same layout, same components. And of course no MOSFETs. Why would you use them? They are expensive, right? This is why Parkside power tools are cheap, I guess. So the first cell, zero point 0.8 volts. Second cell, 1.96. Third cell, 1.02. Fourth cells, sorry, 2.14. And the last one, 0.75. Where do we go from here? Well, I'm guessing I could call the owner and tell him that I could try to put together one or two good battery packs from all of this, recover some still usable cells from this one and the one that has a diode blown up. Let's see if the chargers work. This is the first one. Yeah, green light. Do I have my output? 300. 300. Hey, why does it change? I think it needs communication. Let's see if the chargers do work. I have two of them to check, and I have a working battery here to test them. I have a green light. Do I have a red light when I put the battery on? Yes, I do. Before I open it up, I have to do a disclaimer. These chargers have mains in them, which means they could kill you if you are not careful. So if you are not comfortable opening them, don't do it. Take them to someone who is. Make sure you do know what you are doing before opening this. All this side is deadly, so never ever touch there. I opened it up because I want to check if it does charge. If it is charging my battery. Yes, it is. This is the second charger, which I want to test to make sure it does charge. No socket, no connector. Let's see if it works. I have my green LED. Now I have red LED. And does it charge? Yes, it seems to do. Slowly, but the voltage does rise up. So yes, my spot welder is charged up and ready to go. Oh, and by the way, do not try to use this while it's discharged because it relies on the low resistance of the battery inside. And you only get low resistance when the battery is fully charged. So make sure it is fully charged before you work on it. Now, I have spoken with the owner and he told me to take usable cells from two of the batteries and make two battery packs work. The priority is this bigger one, so I will start with it. One of the packs I will disassemble is this one with the dead BMS, the blown diode. and I think the other is this one. So I have here 4 working cells, all of them close to 3 volts. Yeah, I think this should be enough. There we go. The battery pack is completed, and I made sure to have each different parallel string to over 3.2 volts, hoping that the charger will take care of the rest. The battery pack is completed. Now let's test it. Do I have voltage over 15? Yes. and the outputs. Yes. Before I put the battery pack in its case, I want to see if it's charging. So the charger is plugged up. I have my red LED, and let's test it. So this is the plus and there is the ground. So without the case, it doesn't sit very well in its place. Yes, it is charging. Look, 16.2, 0.25, 0.26, 0.27, 0.28, 29, 16.3. Yes, it is charging. So yay, victory. Let's test it again. Yes, I do have my red LED. So I'll leave this to charge and get to work on the other battery. How much capacity would that repair battery still have? I'm not sure. I'm guessing not that much, but buying new good cells to replace all of them would be more expensive than buying a new battery pack, so I had to make do with what I have. So if the owner is okay with it, then so am I. Let's see this one. Which of the cells is dead? 0.8, 1.9, 1, 2.16, 0.75. Is it worth saving this one? Let's see the other one. 3.6. That's more like it. 3.6. 3.6. Minus 10. Wow. And the last 3.7. Ignore the reverse polarity. So this is the one we will save. The board is finally out. It took a while because, as you could see, lead-free solder is not very cooperative. Now, let's see, do I have my 15 volts or so on the output? 17, yes. So all the cells seem to be okay. This one is also ready. Let's see if we have voltage on the output. We should have, yes, we do. Do I have any LEDs? Yes, the red one, saying that the battery is discharged, but it is connected. Let's see if it's charging. I do have my red LED. And yes, it is charging. So I can put this one back in its case too. So the charger, it is plugged into the mains and it is charging. This battery pack seems to have more charge in it than the bigger one. So maybe it should be able to start my impact gun. Yes, it does. So the battery pack does work. Do you by any chance know if Parkside power tools have under voltage lockout? Meaning, do they stop working when the battery voltage drops below some level? I did try to power this from my programmable power supply, but it didn't work, which tells me that this third pin must communicate with the battery. Not sure what communication, but it doesn't work without the battery. Maybe the BMS, the board inside the battery, tells the power tool to stop working when the voltage drops below some level or there is an unbalanced cell. But this still doesn't explain why all these battery packs died in the same way. The cells completely dead. So yeah, maybe the board inside the battery pack does control when the power tool starts, but I still would have liked to have a BMS with a MOSFET on the minus side, on the ground side, just to cut out the batteries when they are below what, 2.8, 2.9 on each cell, right? Maybe Parkside decided to have their tools different. Not sure. If you know anything about this, please leave it in the comments down below. While I worked on the second battery pack, this bigger one was charging. So let's see. Does it work? Yes. So all they need is a good charge, is a complete charge, and they should be ready to go. This other one is not worth saving because most of its cells are too far gone. So yeah, I will leave it as it is. So we have 2 working battery packs out of 4. And this is where my video ends. The other 2 are not worth saving. We don't have cells. One of them has its BMS board dead. So yeah, I'll leave it at that. Thank you for watching. If you like my video, please give it a thumbs up. Please subscribe and all that YouTube interaction. It really helps my channel. If you want to support me, you can do it by buying super thanks or by becoming a member of the channel. You know what to do. So yeah, hope you liked it. See you soon. Bye.